Welcome everyone to another edition of eRotary Coastal Club. We're got a speakers meeting today. It's January 7th, 2021. Welcome to 2021. And today's speaker, we have Alex Kolker. He's associate professor with LUMCON, which is the Louisiana University's Marine Consortium. And as you'll see in the picture to the right, that's Alex to the left in the it looks like in a center console boat there. And then to the right is a picture, I think it's 2013 was when this picture was taken off a Google Earth picture of the LUMCON site down in Chauvin. When you look at it on the map, it is like right there at the Gulf, and you can see in this picture. And I was just talking with Alex before we got started the meeting of their parking lot flooding. He was mentioning his parking lot floods pretty regularly now, and you can see why. You'll notice that when you take off in a plane out of New Orleans, that it's like the Gulf Coast is right there next to New Orleans. We're losing a lot of our coast very rapidly, and this LUMCON facility is right there in the heart of the action. And so, Alex, what we like to do, I'm going to stop my screen share. We'll let you take over. If you could just explain for us a little bit of background about why you are providing. Working with LUMCON, how you found yourself there, and then what has interested you most about this topic of sea level rise as we prepare for your presentation?
So I came to Louisiana in 2007. I had just finished graduate school up at Stony Brook in marine sciences. They had a very strong marine science program, and I actually studied the response of coastal wetlands around New York to climate change and sea level rise. That was my my PhD thesis was on that. And so I was very familiar with issues of climate change and what they might mean to people in coastal communities in graduate school. And I came to New Orleans in 2007 in the wake of Hurricane Katrina, and I kind of realized that all of these issues that we had talked about in graduate school as hypotheticals that could happen in the future, many of those kinds of issues had just happened in Louisiana. And so it was it was a sort of a wake-up moment in my career, and I've focused on coasts, particularly here in Louisiana, but as I said, I'll say in a minute, abroad, because of that. I've done a lot of coastal work here, and working at LUMCON, I've realized just how important sea level rise is, and I'll show you some about that today. But I'll also talk today. One thing that I've realized is how much coasts are a part of people's daily lives. And last year I had the honor of serving as a Fulbright Scholar, which is a U.S. Department of State sponsored program that basically aims for scholarly exchange across the world and tries to bring about a more peaceful understanding of the world through scholarly exchange. And I'll certainly say if there's anything that we need now, it's a peaceful exchange of ideas. Science is a process that works best in peaceful times when people can freely exchange ideas. And some of the kinds of violence that we've seen in the last couple of days is just incompatible with the scientific process. And I just wanted to make note of that because I think it's so important to say. But it's really an honor to have the opportunity to talk to you all about sea level rise. And so with that, I'll do that. Let me view this slideshow from the beginning. So this is a picture of the Kasbah in the Rabat. This is about 1,000-year-old structure in the Rabat, which is the capital of Morocco, where I had some time to spend. And I'll talk to you about sea level and coasts around the world. The coastal zone is really where the land, the atmosphere, the sea and the atmosphere converge and really converge with humanity. You know, a lot of times when we think about our coasts, we think about these sort of wild and desolate places that like this in the Mobile River Delta in Alabama. We think about wild places like the Wax Lake Delta, or fun places like coasts where people are surfing. But coasts Coasts are really much more than that. This is recreation in the coastal Sahara in Morocco, but coasts are used by people around the world for a variety of purposes. Something like half the US lives in the coastal zone, and roughly half the world lives in the coastal zone, depending a little bit on how you define what is coastal. Coasts have a huge number of purposes. They're important locations for biodiversity. These are some birds that a professional photographer took. This is the scene in San Diego. This is a coastal scene, coastal wash in San Diego. These are incredibly ecologically rich areas. Coastal fisheries are important to communities around the world. This is in Essaouira, Morocco. This is Safi, Morocco. You can see people's boats by the water, and just a tremendous number of people that are making a living working on coasts. So this is coastal Morocco, a scene that looks not too dissimilar from the kinds of scenes that we might see here in Terrebonne Parish in Louisiana. Ports are critical for trade and commerce across the world. This is a port in Essaouira, Morocco, the port of Safi, Morocco. This is Port Fourchon here in Louisiana. This is our nation's largest, or one of our nation's largest oil and gas ports. And it's located, like almost all ports need to be, just at or near sea level. If you look at the population of the world, this is the coastal population of the world. You can see, so the map is color coded. The darker colors, or the brighter redder colors, are areas with higher populations. These are the population in the LECZ, which is like the low energy, which is like basically the low lying coastal zone. And the cities that are highlighted are cities that are mega cities, cities that have over 8 million people. The coastal zone is predicted to increase in populations. If you look at what's projected for population, the number of coastal megacities are expected to grow, and the number of people that live by the coast is expected to grow. People live by the coast because there's fish and there's ports and there are economies there. So you see the coastal zone filled with, you see large cities in the coastal zone, like New York. You see much smaller communities in the coastal zone. This is Ganvi, Morocco. This is a community of people that actually took refuge in a quiet part of the coastal zone, in Ganvi, Benin, which is West Africa. This coasts are used for all sorts of reasons. This is Aqaba in Jordan, and in the background is Eilat in Israel. So you can see, this is both tourism. There's also industrial ports here. There's cities. There are cities and population centers here. Coasts can connect continents and cultures. So this is Northwest Africa. So this is the city of Ceuta in Northwest Africa. This is actually an enclave. The inhabited areas in the foreground are an enclave that is claimed by Spain, that's in Africa. In the background, you have Morocco, and you have Jebel al Tariq, or Gibraltar, on the other side. So these are the Straits of Gibraltar. So this is Africa, and this is Spain. So coasts can in some ways divide places, but they also connect continents and cultures. Actually, if you look at, we think of, there are transatlantic or routes across connecting Morocco to Africa. It's ferry routes connecting Morocco to Africa. On the right here, I have a list of words in the French language that come from Arabic, and of course there's a lot of linguistic connections between Spanish and French and even English words that are from Arabic. And that's, of course, because you had large Arabic-speaking populations in Spain until 1492. And there are plenty of words today in the English language come from Arabic. Sugar, coffee, bananas, apricots, alcohol, algebra, algorithm, all of these words come from Arabic. And to get there, they had to cross the coast. Coasts also played a role in migration, right? The migrant crisis of several years ago had a strong coastal component. A lot of it, the migrant crisis involved people getting on boats and leaving Africa to try to go to Spain and Europe. And of course, they left at sea level. A lot of that involved things that took place at where the sea meets the land. There's a lot of, our world has a lot of history by the coast. This is Sadiki Shakal, which is, it's basically, it's a mirabu. It's basically almost something like a temple that is located along the coast in coastal Morocco. And there's also parts of our coastal history that are much darker. This is a monument. This is in Benin. This is Ouida, Benin. And this is a monument to people that were deported and departed and enslaved and taken from Benin, from places like this in Ouida, Benin, and taken to America. So this is just there is now a monument to the transatlantic slave trade in downtown New Orleans. And I think it's important to remember that our coasts, some of our coastal connections are much more troubling. And I think it's worth remembering that and thinking about that and thinking about the role that our coasts played and even coastal, the forerunners to coastal scientists. All of those boats had navigators and engineers. And I think it's important to think about in this time. Coasts are also changing and waters are rising. So this is south of Lumcon's Marine Laboratory. This is a camp south of Lumcon's Marine Laboratory. This camp was it was a recreational camp that was built on the land decades ago, and it's now out to sea. Some of that reasons out to sea is that the barrier island has moved, and some of it's that the land has sunk, and some of it's that global sea levels have risen. This is Island Road in Terrebonne Parish. You can see there are roads across the state of Louisiana and quite frankly across the country that are located near sea level. Coastal change, including rising sea level, but also including a lot of other changes to the delta, like major hydrological changes. Our coasts are getting saltier as sea levels rise and salt waters intrude. And this used to be, these are trees that used to be tree skeletons that used to be trees. And that's part of our coastal change story. For me, the idea of studying sea level, it started off as really just a professional curiosity, but it's moved into really, in some senses, both an exploration of the personal level of science. This is a view of Lumcon's Marine Center. Our plan for sea level rise was written up in the New York Times. This is the parking lot of my Marine Center in June of 2019 during a day of high tide flooding. Flooding it threatens my ability to get to my job, and so it's both an intellectual curiosity, but it's also a personal concern of whether I'll be able to get to my lab today is a function of, in part, of what's happening with sea level. I pulled together the number of days of flooding at Lumcons Marine Center. I basically looked at a long-running gauge from the U.S. Geological Survey, and the blue and the red and the green are just different, slightly different thresholds at which we flood on this gauge, but they all show roughly basically the same thing. The number of days of flooding that we experience at Lumcons Marine Center has increased substantially. And it's gone from flooding being a relatively rare event in the early part of this century to being an almost every other week kind of event. We now flood 50 to 75 times a year. In some years, some more recent years, even more than that. And so coastal flooding is a major concern. Global sea level rise isn't the only cause of this flooding. There's Louisiana's well-documented land loss, our subsidence, the construction of a levee, but they all combine to give us increased flooding. And in fact, that if you want to get into more of the weeds, that those are some of the details of sea level rise that I'm curious about. I'm really curious about, so this is just a schematic that was put together by the IPCC about why global sea levels rise. And global sea levels rise for a variety of reasons. They rise, sea level rises because climate warms and our glaciers melt. Sea level, so that's one big reason sea level rises. Sea level in some places, and Louisiana is one place, sea level can rise relatively because the land sinks. Sea level can also change because of dynamical processes, because of winds and ocean currents blowing water all across the ocean that can cause waves on shores or shorelines, or winds essentially can force water across the ocean and cause water to pile up on the coast. And for me, that's actually one of the more interesting parts of the sea level equation. And with that kind of perspective, I'll sort of say last year I had the opportunity to participate in the Fulbright program, which was sponsored by U.S. Senator from Arkansas, William Fulbright, in order to basically get people to, it was founded in the wake of World War II, with the idea that if we all understood each other a little bit better, we might be much less likely to fight with each other. And it's really actually a wonderful program that provides people from America to go to universities abroad and people from countries around the world to come to the US. And I had the opportunity to participate in that program in Morocco, and to bring some of my understanding of sea level rise from Louisiana to a different country. In some ways, the coasts are really different, right? Like Louisiana is it's a very flat coast with a big river, and Morocco is like a dry, deserty coast with a lot of cliffs. But in some ways, they're relatively similar. They both have large coastal cities. Morocco's ports are some of the largest in North Africa. Fishing is important to Morocco's economy and diet, and coastal tourism is important to the economy. So as a scientist, I wanted to assemble data from across the region and to understand why sea level was changing. And I wanted to compare records from Morocco and near-time regions of the world to global measures of weather and climate. I said, this is the scene in Rabat and Saleh, and coastal waters are part of daily life for many Moroccans. So I wanted to know how fast sea level is rising across Morocco's coasts and nearby maritime regions, and how are sea level dynamics along Morocco's coast related to regional patterns in weather and climate. That dynamics that I showed you, those slides of winds forcing water on and off across the ocean. These are some of the long-range tide gauges located near Morocco. So there's a lot of tide gauges. So basically tide gauges are, it's just basically like a little station around the water where water measures, where you measure water levels. In the old days, it used to kind of be like a floating bobber. That was a float that was attached to a string that moved up and down, and that was attached to a pen. Now it's done with a gauge that measures and records water levels. I also looked at sea levels from satellites. So this is one graph of sea level determined from satellites, roughly from this area. And you can see sea level on Morocco's coast goes up and down. So there's a strong seasonal signal. Sea level is highest in about March. It's highest in October and low in about March. And you can see that there's a general pattern. There's a long-term trend of about 2 millimeters a year. So there's like some variability, and there's a long-term trend. I was curious about what this was, so I looked at what the seasonal cycle in sea level was, and what I found is, like I said, there's a low in sea level. So these are months in the year, and then this is the sea level. This is the height of sea level in centimeters. And so the low point in the year is in February and March. The high point in the year is September, October. And the seasonal cycle is about 10 centimeters, which is actually relatively high, right? Because global sea level rise rates are only a few millimeters a year. So the annual cycle in sea level is much greater than the long-term trend, or at least in any given year. What was this sea level cycle and seasonal cycle related to? It's in some ways related to patterns in global wind. So if you look at what atmospheric pressure is like, so down here, you've got a map of atmospheric pressure, which I pulled together from global climate records. And the atmospheric pressure in March, so redder is higher pressure, blue and purple is lower pressure. So you've got a big high pressure system centered around the north central Atlantic that in March, this pressure system leads to stronger winds than that blow from Africa to the Caribbean. And then in October, these winds are lighter because the pressure system is weaker. So this is basically like the North Atlantic gyre. These global wind patterns, these are, in some ways, these patterns should be familiar to us in Louisiana. These are roughly the patterns that hurricanes take. Hurricanes start typically they start in Senegal. They go across the global ocean. They hit the Caribbean, and hopefully they don't hit Louisiana. And then they track across to Northwest Europe, to England and Ireland. These are global wind patterns. They also, in addition to influencing the hurricane tracks, they influence sea level. They're part of this system that we often sometimes think of as the North Atlantic centers of action, or the North Atlantic oscillation. There are these major systems of a high pressure system here that we call the Azores High, and a low pressure, because it's centered around the Azores. Sometimes Americans call this the Bermuda High, same thing, and a low pressure system up here that we call the Icelandic Low. This is like the stormy North Atlantic. And these pressure systems drive global winds. You can see a little bit of that seasonal cycle here. This is a photo of Morocco from October and a photo of Morocco from March. Some of that's the daily high and low tide, but some of that is that global sea level cycle, that seasonal sea level cycle. This is a point in the year when we tend to have high sea level, and a point in the year when we tend to have low sea level. So during March, low sea level, you have strong winds to blow water offshore. During October, weaker winds, less offshore wind. If we were to look at sea level rise at several stations across the Atlantic, if we were to look at like one of these stations, so I pulled together satellite records of sea level from across the Atlantic or from across Morocco's coastal regions. So these are just different locations where I pulled together sea level data. You can see that sea level goes, so now we've got a graph here. So this is time, this is the year of 1992 to 2016. And this is sea level in centimeters. Sea level is the blue signal. The pressure of Azores, the Azores high is the high pressure. So you can see that there's some fluctuation between these two. If we look across the coast, some of these fluctuations are related to what I'll call the inverse barometer effect. When the pressure of the Azores high is great, when the Azores high, years when it's particularly strong, you've got a lot of high pressure, which kind of just forces the ocean down. And when you've got a low pressure system, the water bubbles up. This is a little bit like a storm surge, right? One of the reasons you get storm surge is there's a lot of wind. Another reason that you get storm surge is that you've got a low pressure system and the water bubbles up. This is like that second part of the storm surge. If we look at the relationship between sea level and the Azores high, we find that in the stations closer to the coast and closer further down, you see this relationship, this inverse relationship between sea level, between sea level and the Azores high. Like, look at these systems; they track, sea level tracks the Azores high. I'll just say I've got the Azores high plotted backwards. So these are the years of low sea level, of low Azores high pressure, when you would expect a strong inverse barometer effect. These are high Azores high pressure. So I just switched the axis. But the short story, in periods when we think that the Azores high is weak, we get a relative high of sea level across this record. And in years where the Azores high is strong, forcing sea level down, we get sea level low, except for sort of some of the end of the record. We tend to get some discontinuity at the end of that record, right? We see that over here, where we've got a strong coupling between the Azores high and sea level. And then at the end of the record, we're sort of getting a decoupling. You can see that in a number of stations in here, this strong relationship and then a decoupling at the end. And what I'm suggesting may be happening is that the global sea level rise is changing the relationship between sea level and between sea level in the Atlantic and the Moroccan Atlantic, and the intensity of the Azores high. And in years when sea level and we are losing that, possibly in part because global sea level is rising faster, that the climate change signal is outweighing the meteorological signal. So people often ask, is climate change some kind of natural cycle, or is it some kind of change? And this suggests it's a change in the way this suggests, and there's still more work to do, but that this is kind of what the natural cycle might look like. And this is what happens when we start seeing climate change. We start seeing a disruption in some of those natural linkages. If we pull all of this together for sea level rise for Morocco, we get an average rate of sea level rise in Morocco that's about 2 millimeters a year. So sea level is rising, and it's probably accelerating. But interestingly, it's a little bit lower than the global average. So the maritime Maghreb, the area in and around Morocco, has a rate of sea level rise of about 2 millimeters a year. this is a graph of sea level rise in the northern hemisphere, showing the northern hemisphere rate of sea level rise is about 2.8 millimeters a year. If you look at the global average since about 1992, the global average is about 3.5 millimeters a year. And so sea level is rising in the Mediterranean. So sea level is rising in Morocco, but it's rising less than the global average. If you look at some other satellite data of global sea level rise, this puts it in a different perspective, and you can see low rates of sea level rise along Northwest Africa and higher rates of sea level rise along the Gulf and Atlantic coast of the US. And what I speculate is that's the global winds. That is winds that blow water from Africa to North America that cause water to pile up on the Northwest coast on the Americas. So we're forcing water across the ocean. And so what I'd say is, sea level dynamics play an important role in Morocco's coast, and the seasonal cycle in sea level, coupled with interannual, and so sea level rise rates in Morocco are, lower than in many. Let me go to these concluding thoughts. I think I wrote it better here. Sorry about that. So I'll just sort of end with these concluding thoughts, and these concluding thoughts are that coasts are places where the land, the atmosphere, and humanity converge. And sea level rise, which is closely tied to changes in climate, weather, land use, and local human activities, threatens to disrupt coastal systems. If we look at the case of Morocco, Morocco's low rates of sea level rise are the fact that Morocco's low rates of sea level rise are linked to high rates of sea level rise along the American Atlantic coast exemplifies sea levels, global and local connections. And I'll just end with understanding these changes and what to do about them requires both a global perspective and a local perspective. You need a global understanding of what's happening with sea level, but you also need people that know their local system and know the local area. And one thing that I've learned about, as on a personal level, about working in Louisiana and then trying to work in some other systems is how much time it takes to really understand a local system. And you really need people that have a global perspective, and really need to work with people that have a detailed understanding of the local area as well. And with that, I'll just say thank you. Want to say thanks to Rotary for inviting me to give this talk. I want to thank LumCon, my home university, my home institution. And I want to thank the Fulbright program for providing this great opportunity for intellectual exchange, and my host universities in Morocco, Qadi Ayad University and University Mohammed VI. And so with that, I'll just say thank you.